training methods used by today's athletes are based on the topics previously introduced in this video: functional anatomy, biomechanics, and in particular, exercise physiology. A knowledge of these scientific disciplines can be applied by the athlete to the design and monitoring of his or her individual training program. The aim of the training program is to develop the abilities or physical capacities of the athlete so as to match as closely as possible the requirements of the chosen sport. There are 3 stages in the process of designing the training program. Firstly, the particular requirements of the chosen sport are analysed. Secondly, the physical capacities of the individual athlete are measured. And then, by combining this information and by using the basic principles and methods of training to provide a framework, a tailor-made program can be drawn up. The first step in the design of the training program is to analyse the detailed requirements of the chosen sport, game, or event. This analysis is based on a knowledge of the body systems and how they perform. The requirements of the sport can be plotted on a chart. Start by considering the duration and intensity of the game or event. This will show the predominant energy pathway or pathways used. Jody is interested in middle distance running. Because this is an endurance event, most of the energy required is produced aerobically. However, to win races, the endurance athlete must be able to produce surges during the race to wear down the opposition, as well as putting in a big sprint finish to clinch victory. This additional energy requirement exceeds the anaerobic threshold and therefore can only be met anaerobically. So distance events rely mainly on a good aerobic capacity for endurance, but also require anaerobic fitness for bursts of speed. Scott is a promising water polo player. Like most team games, water polo requires high fitness levels in a number of areas. General play such as marking, getting into position and following the game requires endurance, making use of the aerobic pathway. Sustained bursts of speed call for efficient anaerobic energy replenishment and an improved ability to tolerate the effects of the buildup of lactic acid. Making long passes and shots at goal require maximum explosive power. This is produced by ATP and CP splitting. A team game player also needs strength and agility to outperform the opposition. Using the chart, the requirements of the sport can be clearly shown. Endurance events, for example, require a highly trained aerobic capacity and also a good anaerobic capacity and lactate tolerance for sustained bursts of speed. Team events have a broader range of requirements. high levels of efficiency are required in all the energy pathways, aerobic, anaerobic, and ATP-CP splitting. Strength, agility and power are also very important. The next stage is to see how the athlete's physical capacities match up to the requirements of the sport.
Thank you, Max. Set.
The physical capacities of an athlete can be analysed using a series of simple tests. This is the 1.6 kilometre run, which is a test of aerobic endurance.
Come on, Charlie.
This is the 50-metre sprint, which tests anaerobic power. Explosive muscular power is tested by the standing broad jump. Arm and shoulder strength are tested by the 1 repetition maximum bench press. Sit-ups test abdominal strength and endurance. Push-ups test arm and shoulder strength and endurance. Joint mobility and flexibility are tested by the sit and reach. And the shuttle run tests agility. Then, using the results of these tests, the physical capacity profile of the individual can be drawn on the chart and compared with the requirement profile of the chosen sport. Correct training over even a few weeks produces a marked improvement in performance. This is achieved by the modification or adaptation of the body systems to meet the demands of the training load. However, adaptation will only occur if the training load is of the correct intensity. If the training load is only a little greater than everyday activity, it will be too light to produce adaptation, and there will be no significant increase in performance. On the other hand, if the training load is too heavy, the athlete will become fatigued and performance will not improve. This is called failing adaptation. The correct training load, which produces effective adaptation, lies in the adaptation zone between these two extremes. In order to achieve adaptation, a heavy training load is imposed on the body systems. Because this load is at or near the existing limits of the athlete's performance, it's called an overload. After a number of training sessions, the body adapts to the overload and performance improves. Once an improvement has been achieved, the training load can be increased. The body adapts and performance is further improved. the training load can be increased again and again, and performance improves and improves until the athlete's upper limit is achieved. This process is known as progressive overload. It's important to realize that this principle can be applied to all the body systems, including the muscles, the energy pathways, the circulatory system, the respiratory system, and the nervous system. Training should concentrate on improving the specific aspects of performance required by the chosen sport. The movements used in training should resemble those used in competition. This develops the specific muscle groups used and develops coordination and skill. These are specific exercises designed to improve stride frequency and length and acceleration in the sprinter. The specific energy pathways used in the sport should also be identified and trained. The endurance athlete must develop the aerobic capacity to the full, but must also train for lactate tolerance. Like progressive overload, the principle of specificity applies to all aspects of training, for example, flexibility. The need for specificity also applies to acquiring a skill. The specific movements of a sport should be practiced and, whenever possible, the pressure and speed of competition should be simulated. So, in order to meet the specific requirements of the sport, specific training is used and specific improvement results. There are a number of fundamental training methods which can be adapted to suit the needs of the individual athlete. The first of these, over-distance training, is an application of the overload principle. The athlete trains over a distance greater than the actual competition distance. This overloads the muscles and energy pathways, leading to improved endurance in both. Over-distance training can be used very effectively for events of all distances, sprints, middle and long distances. Continuous training is a method of conditioning used to specifically improve aerobic capacity and therefore endurance. This involves training for long periods below the anaerobic threshold. In this steady-state condition, energy is provided almost completely by the aerobic pathway. To achieve effective adaptation, the heart rate should be between 70 and 85% of maximum. This can be tested after 10 minutes of training.
Yeah.
Good. Start counting now.
Another test is the talk test. It's usually possible to talk freely when training below the anaerobic threshold. Continuous training is essential for endurance events, but it's also used to give a foundation of aerobic fitness for shorter events and team games. During continuous training, the athlete can vary the pace by adding short bursts of more intense work. This is called speed play. These bursts of speed are powered anaerobically, and so both the anaerobic and aerobic pathways are improved. Speed play is a good description because there's no set pattern for the variations of pace. This is valuable because it conditions the athlete to meet changes of pace during competition. For the less experienced athlete, speed play training also helps to introduce the stricter discipline of interval training. Interval training is a very versatile and very productive training method. It involves repeated periods of intense work, alternating with lower-level recovery periods. Interval training is used for running and swimming events, from sprints to middle distance, and for team games. It allows the athlete to train with the high training loads that will eventually produce competition performance. These high training loads can be used because of the built-in recovery periods. For example, a race distance can be divided into a number of parts. Each of these can then be run or swum at competition pace, with a recovery period in between. This allows the body systems to adapt to the competition pace. The recovery periods can then be gradually shortened until finally the whole distance can be attempted at competition pace. There are, in fact, 4 ways in which the interval training routine can be varied to suit the needs of the individual athlete. These variables are the intensity of the training load, the length of the work period, the length of the recovery period, and the number of work and recovery cycles. Each of these variables can then be precisely manipulated so as to progressively increase the training load and thus performance. Interval training is also used in cycling. Here the coach is using an electronic timer to help to regulate the work and recovery periods. Progressive resistance training is the term applied to strength training using weights. This is a direct application of the principles of overload and progression. The athlete starts with a weight or resistance, which overloads the muscles, but which lies within the adaptation zone. After a number of training sessions, strength improves. This allows the resistance to be increased. This in turn produces a further improvement in strength, and the process can be repeated until the athlete's full potential is reached. Progressive resistance training can be used in any sport requiring strength. It's particularly useful in improving the performance of specific muscle groups. Circuit training is a very useful method of organizing a group training session. A number of different exercises are performed at points or stations around the gym or training area. Each athlete moves from one exercise to another until the circuit is completed. It can then be repeated one or more times, depending on the desired training load. Muscular endurance is achieved by using a large number of repetitions with a small resistance. On the other hand, strength is developed by using a small number of repetitions and a heavy resistance.